Okay guys, so after working in class for the last few days, there's a bunch of different formulas and a bunch of different sort of ways of writing equations that we need to know, and I thought it might be helpful to go through all of that information one more time in a video so you have everything in one spot. So we're going to start today with reviewing section 4.1 to 4.3. And here are some formulas that we know so far in this chapter. The first formula we know is what's called slope-intercept form. And slope-intercept form looks like this: y equals mx plus b. Now the reason that this is called slope-intercept form is that in this equation, the m, which is usually a number, so usually this equation will have numbers in it, the m is the slope, and the b, which again is usually a number, the b is the y-intercept. An example of an equation that is written this way is y equals negative 2x plus 7. In this equation, the slope would be the negative 2 and the y-intercept would be the 7. Now the second equation that we should know from this chapter is point slope form. And the reason it's called point slope form is that in the equation, instead of having the slope and a y-intercept, we have a point from the graph, like an ordered pair, and the slope. So this equation looks like this: y minus y1 equals m parentheses x minus x1. In this equation, the slope is still m. But instead of having a y-intercept, which is a very specific point from the graph, we have any point from the graph. So we don't need a y-intercept anymore. We could use any point. The x1 is the x-coordinate of any point, and the y1 is the y-coordinate of any point. An example of how this equation might look is y minus 7 equals 1/3 parentheses x plus 2. Now, the x-coordinate and the y-coordinate are next to their corresponding letters. So like the x is next to the x and the y is next to the y, and the slope is always the number outside of the parentheses. The last thing is formula for finding slope. So you'll notice that we need to know what the slope is to write both of these equations. So we have a formula that we can use to find the slope of a line when we don't have a graph. So if we have a graph, we just do rise over run. But if we don't have a graph, we use the formula y2 minus y1 over x2 minus x1, where these are the y-coordinates of 2 points, and these are the x-coordinates of 2 points. Now we should remember that if you have a graph, you don't use this formula. You just count the boxes and you do rise over run. You only use the formula if you don't have a graph and you have two ordered pairs. So let's practice finding the slope really quick. Find the slope of a line that goes through the following points or is graphed in the picture. So for option number 1, where we don't have a picture, we're going to use our formula y2 minus y1 over x2 minus x1. Now, sometimes we can start by labeling in the points what numbers are what. So in the first point, we have x1, y1, and in the second point, we have x2, y2. If we take those numbers now and fill them into our equation, we're going to have 5 minus 3 over negative 1 minus negative 2. Now 5 minus 3 is 2. And two minuses, like see here where we have a minus, -2, make a plus. So -1 plus 2 would be 1, which means my final answer would be 2. If I gave you, for example, in number 2, 2 points, but that were written in function notation, so just the same thing but a slightly different notation, we would still use that same formula, y2 minus y1 over x2 minus x1, and we would still label x1, y1, x2, y2, and we would still fill in our numbers. So we would have 4 minus 5 over -1 minus -3. Now again, these two minuses make a plus, so we would get -1 over 2 as our final answer. However, if I give you a problem like number 3 where you have a graph, you're going to notice that instead of using this formula, I'm just going to count rise over run. So if I start here, I would rise 3 and I would run 2. So my answer would just be 3 over 2. Now that we've reviewed slope, let's review some special kinds of lines that sometimes come up when we're talking about slope. So here are some things to remember about slope. If you have a vertical line, which means the line looks like this, so you have a graph, and you have a line that is vertical, the slope of a vertical line is always undefined. Now we can remember that by remembering VUX, like Vuxhoy. The U stands for undefined slope. If you have a horizontal line, which means it looks like this, the slope is always 0. And we can remember that by remembering Hoy, because the 0 stands for 0. If you were doing algebra and you were calculating things, like you were doing it with numbers, if you end up with a number over 0, that means that it's undefined. Whereas if you end up with 0 over a number, that means that it's 0. So the way that I remember that is that a 0 on the bottom is no, it's not okay, so the answer is undefined, and a 0 on the top is okay, so the answer is just 0. Now let's review that after we've reviewed slope a little bit, let's review how to actually do these equations, which require us to have a slope. If I say, for example, write the equation of a line that is described in slope-intercept form, you need to know when you read these directions that slope-intercept form means y equals mx plus b. I'm not going to tell you that that's what that means. You need to know those vocabulary words. So for problem number 1, where it tells me the slope and it tells me that the y-intercept is 4, I can just plug those numbers into the equation. So y equals 2, which is the slope, x plus 4, which is the y-intercept. However, in problem number 2, where it doesn't tell me the slope and the y-intercept, instead it tells me 2 ordered pairs, step number 1 is going to be to figure out the slope. So I would do 5 minus 3 divided by -1 minus -2, and I would get 2 over 2 negatives plus 1, which is 2. My second step would be to write point slope form. I can't just jump straight to slope intercept. I have to start with point slope. So I would have y minus the first y, which is 3, equals the m, which I just calculated, x minus the first x, which is -2. So because I'm minusing a negative, it becomes a positive. And then I would have to rearrange. Now I noticed a lot of students struggling with the rearranging. We need to remember the process of solving equations, which we actually learned in Chapter 2, our very first chapter of the year. So whenever there's a parentheses, we start with distributing. So then we would have y minus 3 equals 2x plus 4. Then we add the 3 to get y by itself, and we get y equals 2x plus 7, which is slope-intercept form. So this would be my final answer, but to get there, when you have two ordered pairs, you have to start with point-slope form and then rearrange it. The last thing would be to look at a graph. So on a graph, I would need to start by making a list of what my slope and what my y-intercept are. To get my slope, I would do rise over run. So starting from here, I would rise 3, run 2. My y-intercept is where I cross the y-axis, so that would be at the 2. And then if I combine that information, I would get y equals 3 over 2x plus 2. And that would be my final answer. Now let's say instead of saying write your equation in slope-intercept form, the problem said write your equation in point-slope form. Then we would use the formula y minus y1 equals m parentheses x minus x1. And you need to know that. That is not something I'm going to tell you. You need to know these formulas when you see the words. So if I tell you in the directions, here's your point and here's your slope, then we're going to fill in these numbers. Now, the first number in your point is your x, and the second number in your point is your y. So when we fill in our equation, it looks like this. Y minus whatever the y is, so 2, equals your m, which based on these directions is negative 1/2, parentheses, x minus whatever your x is, which is negative 3. So that negative turns this into a positive, and I get plus 3. And then I'm done. For problem number 2, if I give you two ordered pairs, the first step is going to be to figure out the slope. Because in order to do point-slope form, I need a point and I need a slope. It's in the name. And I've got 2 points, but I don't have any slopes. So I would do 4 minus 5 divided by negative 1 minus negative 3. And I would get negative 1 divided by, these two minuses turn into a plus, so I would get 2. Then I would fill in my point-slope form. Now I'm going to use the first x and the first y. You could technically use either one. It doesn't matter. So then I would have y minus whatever the y was, which is 5, equals your m, which we just figured out. So negative 1/2, parentheses, x minus whatever your first x is, which is a negative 3. So it turns this into a plus 3 because two negatives make a positive, and I'm done. Now the last thing you need to know how to do in this chapter, the very last thing, is to graph these lines without rearranging the equation. So you'll notice here that these lines are written in point-slope form, which means I need to list the point and the slope that the lines go through before I can start graphing. Now a point always has an x and a y, and the slope is the easy one because the slope is just whatever is outside of the parentheses. To find the x, I look by the x. And the x and the y here are always the opposite of what you see. From the equation. So here's what that means. If it looks like this is a positive 4, it was actually a negative 4 to start with. If it looks like this is a negative 3 by the y, it was actually a positive 3 to start with. Now I'm going to graph my point. So I'm going to go left 4, up 3, put a starting point there. And then from there, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2. And I'm going to draw my line. Now for the next one, we're going to do this one more time. Again, when I see that the equation is written in point-slope form, I'm going to write down the original point and the original slope that must have been there. The slope is the easy one because it's outside of the parentheses. The point, we need to look by the x to get the x, and if it looks like a -5, then it was originally a +5. And we look by the y to get the y. If it looks like a +2, it was originally a -2. And now to graph this point, I would go over 5, down 2. And to graph the slope, I would go down 2, right 1, down 2, right 1, down 2, right 1, because this is really -2 over 1. Or I would go up 2, left 1, up 2, left 1, up 2, left 1. And then I would draw my line. Okay, I hope this was a good review of what we've learned so far, and I hope it's helpful. Thank you so much for watching, and I will talk to you tomorrow.